Welcome to our journey through the electrifying history of electricity. From ancient discoveries to modern marvels, let's explore the key milestones that have shaped our understanding and use of this powerful force. Imagine a world shrouded in darkness, where fire was the only source of light. That was our reality for millennia until we stumbled upon a force so fundamental, so ubiquitous, that it would forever change the course of human civilization. This is the story of how we unlocked the secrets of electricity, a story spanning continents and centuries, driven by curiosity, ingenuity, and the relentless pursuit of knowledge. Buckle up, because we're about to embark on a journey that's shockingly fascinating. Our story begins in ancient times, long before the scientific method, when the world was a place of mystery and wonder. Imagine early humans witnessing the awe-inspiring power of lightning, a force so powerful it could split trees in half, start fires and even kill. It was both terrifying and mesmerizing. But lightning wasn't the only clue to the existence of electricity. The ancient Greeks, those original scientific rock stars, observed something curious about amber, the fossilized resin of trees. When rubbed with fur, amber would attract small objects like feathers or bits of straw. They didn't know it then, but they had just discovered static electricity. Let's travel back to 600 BC and meet Thales of Miletus, one of the 7 sages of Greece. This philosopher, mathematician, and all-around genius is credited with the first recorded study of static electricity. Thales, like those who came before him, was fascinated by amber's strange ability to attract objects after being rubbed. He believed that this force, which he couldn't see or fully understand, was a fundamental property of the amber itself, like its color or texture. Little did he know he had just opened the door to a whole new field of scientific inquiry. The ancient world wasn't done revealing its electrical secrets just yet. Across the Mediterranean, another electrifying phenomenon was puzzling naturalists. Fishermen were reporting strange encounters with fish that could deliver a painful shock. We're talking about electric rays, like the torpedo ray, capable of generating powerful electric discharges to stun prey and deter predators. Pliny the Elder, the Roman author and natural philosopher, even documented these electric fish in his writings, describing their shocking abilities and the numbing sensations they produced. Imagine the tales these fishermen would spin, stories of fish that could knock a grown man off his feet with a single touch. Fast forward to the 16th century, a time of great scientific awakening in Europe. The Renaissance was in full swing, and scholars were challenging long-held beliefs and making groundbreaking discoveries. Enter William Gilbert, an English physician and natural philosopher who dedicated himself to understanding magnetism and electricity. In 1600, Gilbert published his magnum opus, De Magnete, a groundbreaking work that distinguished between magnetism and static electricity for the first time. Gilbert coined the term electricus from the Greek word for amber, electron. He argued that these electricus materials attracted objects because of an effluvium, a subtle fluid or emanation they released when rubbed. While his theory of effluvium would later be disproven, Gilbert's work laid the foundation for future electrical discoveries. The 18th century saw electricity transformed from a curiosity to a subject of serious scientific investigation. Experimenters across Europe were eager to generate, store, and even discharge electricity, leading to the invention of a groundbreaking device, the Leyden jar. Imagine the shock and excitement in 1745 when Ewald Georg von Kleist, a German cleric, and Peter van Musschenbroek, a Dutch scientist, independently invented this early form of a capacitor. The Leyden jar, a glass jar lined inside and out with metal foil, could store static electricity, like capturing lightning in a bottle. No story about electricity would be complete without mentioning the one and only Benjamin Franklin, a true polymath and one of the founding fathers of the United States. Franklin was deeply fascinated by the mysteries of electricity and conducted numerous experiments to understand its nature. His most famous experiment, of course, involved flying a kite during a thunderstorm. Franklin, ever the careful scientist, knew that lightning was dangerous, so he equipped his kite with a pointed wire to attract the electrical charge and a silk string attached to a key. When he saw the fibers of the string stand on end, he knew that lightning was indeed electrical in nature. This groundbreaking discovery led him to invent the lightning rod, a device that protects buildings and ships from lightning strikes. While Franklin and others were busy unraveling the mysteries of static electricity, a new chapter in the story of electricity was about to be written. The 19th century dawned with a groundbreaking invention that would change everything: the battery. Enter Alessandro Volta, an Italian physicist who in 1800 created the first true battery, the voltaic pile. Volta's pile consisted of alternating discs of zinc and copper, separated by cloth soaked in salt water. This ingenious arrangement produced a continuous flow of electrical current. Unlike the brief discharges of the Leyden jar, the voltaic pile was a game-changer, providing scientists with a reliable source of electricity to power their experiments and paving the way for a new era of electrical innovation. Faraday's breakthrough, the dance of electricity and magnetism. The stage was now set for one of the most important discoveries in the history of electricity: electromagnetic induction. Enter Michael Faraday, a self-taught English scientist who would unlock the key to generating electricity on a grand scale. Faraday was fascinated by the relationship between electricity and magnetism. In 1831, he made a groundbreaking discovery. When he moved a magnet near a coil of wire, an electric current flowed through the wire. This phenomenon, known as electromagnetic induction, is the fundamental principle behind electric generators and transformers, devices that would soon power the world. The War of Currents, Edison versus Tesla. The late 19th century witnessed a clash of titans, a battle of ideas that would determine the future of electricity distribution. In one corner stood Thomas Edison, a prolific inventor known for his direct current DC system, which delivered a steady but limited range of electricity. In the other corner was Nikola Tesla, a brilliant Serbian-American inventor who championed alternating current AC. The War of Currents, as it came to be known, was a fierce competition between these two visionaries. Edison's DC system was initially favored, but Tesla's AC system, which could be easily transmitted over long distances, eventually prevailed. The adoption of AC paved the way for the widespread electrification of homes and industries. Let there be light, the dawn of the electric age. With a reliable way to generate and distribute electricity, the stage was set for its transformative impact on society. No invention better symbolizes this electric revolution than the incandescent light bulb, a technological marvel that banished darkness and illuminated the night. While Thomas Edison is often credited with inventing the light bulb, it's more accurate to say he perfected it. Edison and his team of researchers at Menlo Park developed a practical, long-lasting incandescent bulb in 1879. This invention, along with the development of power plants and electrical grids, ushered in the electric age, forever changing the way we live, work, and interact with the world. The power of curiosity, an electrifying future. And there you have it, from ancient sparks to modern grids, these milestones have illuminated our path to understanding and harnessing electricity. Thanks for joining us on this electrifying journey. But our journey doesn't end here. As we rely more and more on electricity, it's crucial to remember the power of curiosity and the importance of scientific exploration. The story of electricity is a testament to the human spirit's insatiable thirst for knowledge and its ability to unlock the secrets of the universe. Who knows what other electrifying discoveries await us in the future? Perhaps one day we'll harness the power of fusion, the same energy that powers the stars, or develop even more efficient ways to generate and store electricity. The possibilities are as limitless as the universe itself.